Hi, in this video we would like to solve two questions from a final exam for the course Probability and Random Variables, especially for electrical engineering. The first question is asking to find the mean and the variance of the random variable y given the probability density function shown in figure 1. So to solve this question, to find the mean and the variance, first of all, we know that the mean of y is given by the expectation of y, and the variance of y is defined as the expectation of the random variable y squared minus the mean of the variable y to the power of 2. So in this case, we need to find the expectation of y, which is defined as the integral from minus infinity to infinity of y times the PDF of the random variable y, and the expectation of y squared is defined as the integral from minus infinity to infinity y squared fy of y dy. So now the challenge is to find the expression, the mathematical expression of the PDF of y. First of all, you can see that this function is composed of two subfunctions. The first one is the delta function. The delta function is placed at 1 and has an area equal to 1/3. This is not the height. Be careful. In engineering, this is considered as the area under the delta function. So in this case, this is given by 1/3. So f y of y is equal to 1/3 times delta y minus 1 plus the second function. It's a pulse, which is given by 2/3 for y between 3 and 4 and 0 otherwise. So how do we calculate the mean in this case? So to find the mean, the expectation of y is equal to, so the integral, we distribute the integral, so that will be 1/3 times the integral from minus infinity to infinity of y delta times delta y minus 1 dy plus, as you can see here, the other integral only is non-zero only between 3 and 4, so it's 2/3 times the integral from 3 to 4 y dy. Now what happens here, remember that the theorem says that if you have a function h of x multiplied by x minus x naught, this is equal to h of x naught times delta x minus x naught. So in this case, this becomes a constant. Also, remember that the integral from minus infinity to infinity of delta x minus x naught dx is equal to 1, which is the area under the delta function. That's how it's defined. So in this case, we know that this function, the expectation of y becomes equal to 1/3 integral minus infinity to infinity 1 times delta y minus 1 dy plus 2/3 the integral of y is y squared divided by 2 from 3 to 4, and this will be equal to 1/3 times 1 plus 2/3 times 1/2 times 16 minus 9. 2 with 2 cancels out, and that will be equal to 1/3 plus 7 over 3 and the final answer is 8 over 3. Now, what about expectation of y squared? And this is equal to 1/3 times the integral from minus infinity to infinity of y squared delta y minus 1 dy plus 2/3 integral from 3 to 4 y squared dy. So here the answer will be reduced to integral from minus infinity to infinity. Again, this is 1 square times delta y minus 1 dy plus 2/3 times y cubed over 3 from 3 to 4. So that will be equal to 1/3 times 1 plus 2 over 3 times 1 over 3 times 4 cubed, which is 64, minus 3 cubed, which is 27. So that will be equal to 1/3 plus 64 minus 27 is 37. So 2 times 37 divided by 9. And the final answer will be 3 plus this will be 74 divided by 9, which is equal to 77 divided by 9. So we found the mean. That's part A. And part B, to find the variance, we just take y squared minus the square of the mean. So that will be 77 divided by 9 minus 8 over 3 square. So 77 divided by 9 minus 64 divided by 9, and the answer is 13 divided by 9. And always make sure that this is positive. It cannot be negative. The mean can be negative, but the variance is always positive.